Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss the fundamentals of alternating current. Electric current whose magnitude changes continuously and direction reverses periodically with time is known as alternating current. Alternating current, which varies sinusoidally with time, is given by I is equal to I0 sin omega t, where I0 is the peak value or amplitude of AC, omega is its angular frequency. If t be its time period, then we have omega is equal to 2 pi by t. Therefore, we have I is equal to I0 sin 2 pi by t into t. Mean value of AC is that value of steady current which will send the same amount of charge through a resistor in a half cycle of AC as is sent by the alternating current in the same time. To understand this, let us consider one half cycle of AC from time t is equal to 0 to t by 2 as shown in the figure. Let us divide the time interval into n equal parts. Therefore, time interval of each part is t is equal to t by 2n. When n is made very large, t becomes very small such that the current may be assumed to be constant in one small time interval t. Let I1, I2, etc. up to In be the currents in these n intervals of time. Therefore, charge sent by AC in these intervals are Q1 is equal to I1t, Q2 is equal to I2t, etc. up to Qn is equal to In into t. Therefore, total charge delivered in time t by 2 is Q is equal to Q1 plus Q2, etc. up to Qn, which is equal to I1 plus I2, etc. up to In into t by 2n. If Im be the mean value of AC, then Q is equal to Im into t by 2, which gives Im into t by 2 is equal to I1 plus I2, etc. up to In into t by 2n, which implies Im is equal to I1 plus I2, etc. up to In divided by n. Therefore, mean value of AC is equal to the arithmetic mean of all the currents. Now, let us establish a relation between mean value and peak value of AC. Instantaneous current is I is equal to I0 sin omega t. Therefore, charge sent in a small interval of time dt is dq is equal to I dt, which is equal to I0 sin omega t into dt. Therefore, charge sent by AC in time t by 2 is q is equal to integral I0 sin omega t into dt from 0 to t by 2, which is equal to I0 into minus cos omega t divided by omega from 0 to t by 2, which is equal to minus I0 by omega into cos omega t by 2 minus cos 0. Since omega is equal to 2 pi by t, we have omega t is equal to 2 pi. Putting these values and simplifying, we get q is equal to I0 t divided by pi. If Im be the mean value of AC, then q is equal to Im into t by 2. Therefore, Im into t by 2 is equal to I0 t divided by pi, or Im is equal to 2 by pi into I0, which is equal to 0.636 into I0. RMS value of AC is that value of steady current which when passed through a resistance for a half cycle of AC produces the same amount of heat as is done by alternating current in the same resistor in the same time. Here we do the same division of the time interval as in the previous case. The heat produced in resistance R in these time intervals are H1 is equal to I1 square RT, H2 is equal to I2 square RT, etc. up to Hn is equal to In square RT. Therefore, total heat generated in time t by 2 is H is equal to I1 square plus I2 square, etc. up to In square into RT by 2n. But H is equal to IRMS square into RT by 2. Equating the two and simplifying, we get IRMS is equal to root over I1 square plus I2 square plus etc. up to In square divided by n. Now the relation between RMS value and peak value of AC. Instantaneous current is I is equal to I0 sin omega t. Therefore, heat produced in R in a small interval of time dt is dH is equal to I square R dt, which is equal to I0 square R sin square omega t into dt. Therefore, heat produced in time t by 2 is H is equal to integral I0 square R sin square omega t into dt from 0 to t by 2. Putting sin square omega t is equal to 1 minus cos 2 omega t by 2, we get H is equal to I0 square R divided by 2 into integral dt from 0 to t by 2 minus integral cos 2 omega t into dt from 0 to t by 2. Now, the second integral is equal to integral cos 2 omega t into dt from 0 to t by 2, which is equal to sin 2 omega t divided by 2 omega from 0 to t by 2, which is equal to sin omega t minus sin 0 divided by 2 omega, which is equal to sin 2 pi minus sin 0 divided by 2 omega, which is equal to 0. And integral dt from 0 to t by 2 is equal to t by 2. Therefore, we have H is equal to I0 square R by 2 into t by 2. But we have H is equal to IRMS square R into t by 2. Equating the two and simplifying, we get IRMS is equal to I0 by root 2, which is equal to 0.707 into I0.